let's get started with the next session. So where were we? I was trying to get that stuff done with the matrix stuff. Yeah, exactly. So I was trying to get to the derivative loss and get basically that code to work. So run. What was the problem here? I mean, that was kind of running okay, I think. And then the problem was basically, where am I looking at? So it's back with the I, shape error, matrix size mismatch, 5, 3 plus 1, 3. Yes, there we go. I guess that's the problem, right? The question is whether this is the right thing to do. Whether this was the old main, how I was shaping all this stuff here. Init b1 hidden size 1. Exactly. It's the opposite. 3. I'm just like, I don't know. I don't think this is dyslexia, but I keep having a problem with columns, rows, and whatnot. I do believe this is then hidden size 1. I think. And I think then that here applies the same. Output size 1. I believe. Let us run this again. Stop. Let us run this again. 1, 5 plus 5, 1. Size mismatch. Where's that problem? Where is that a problem now? Hidden size. Oh man, what is that a problem now? Yeah, it should be, I guess, in this case, you cannot cast that. Because here you can still cast that, like, kind of, add like nature. I think there's just something that, from a personal perspective, makes that okay. Because adding, obviously, should kind of be the same size, right? But essentially, these biases. Why is it like that? Do they really need to be like these biases? Why? Input size, hidden size. What should be the shape of the biases matrices in standard neural network? The hidden layer. First layer, the bias for this layer actually the same number of elements as there are inerrants in the hidden layer. Okay. But then I don't understand why. What about the weight matrices then? They are connecting, yeah. Yeah, well, of course, that kind of makes sense. Does it make sense? Oh, yeah, it kind of makes sense, right? So you've got the input is a the input is a one one row, one column, and then you have another layer here, so you kind of want something that transforms these to that. So it's got to be like, it's got to contain the 2 dimensions in there, and then this stuff just needs to add. So maybe that was just P2. To be honest, To be honest, W2 is hidden size, output size. So, where is that actually happening? Is that happening here? 5-1. Huh? Or is it that maybe we need to be a bit more specific with this kind of stuff when it comes to when it comes to these? Bunny wrapper, matrix size mismatch, 1.5. But why is 1.5? That makes no sense. Unless, again, that is the problem. So in SymPy, the first size variable is rows or columns, or what is the dimension? Like I get lost with this stuff. Rows. So this would be like, it's like a column, one column. Yeah. This is like there has to be a better way to, there has to be an easier way to think about this kind of stuff. It's just me. I'm like, I don't know. This is dyslexia or whatever it is. Okay, still a problem. 10-1 and now 10-5. What the fuck? The input size is input size, and then we've got input size by hidden size. That's fine. Input size is 10. Fine. 10. So you've got 10 and then 10, like it's a column. So you've got 10 in one column. Then you've got I could use like a Paint app here, and I used to have one extension that I almost built, but I'm like too lazy to open Paint. Well, that's not Paint because I'm on a Mac now. So anyway, so we've got we don't need visual aids, come on. 10, and then we've got basically, yeah, this makes no sense. 10, no, that should be this should be then hidden size, input size, shouldn't it? Input size, hidden size. Fuck, we're doing a transpose. That's why. Shit. Okay, we're doing a transpose. And that's what we're not doing here. That's why. We're transposing it. So I should maybe we're transposing it, and here we're not, so we're transposing x. Let's just go back to where we had it. Here, I think that's where we left it, and that's what was breaking at the beginning, right? Yeah, 5-3, exactly. And now we're saying transpose AI. How do we transpose in SymPy? Here, for example, x instead of x. Okay. So that should do it. Let's see what happens. Still getting a problem. But it's not the same problem like it used to be before, right? So we transpose x so that we can do then input size and then the matrix W. So this is one. Oh no, this is one row like this, right? Then we transpose it, and then we have basically input size so that each of this element input size hidden state 10 by 5. So you can't multiply that, obviously. Why? What's going on here, right? So we've got input size, hidden size, and then we've got hidden size 1. That's fine. But then x is defined as what, man? That's fine. Should be input size 1. That just feels like stupid, man. So stupid. Now the problem is with the addition. Because input size is 10, so we've got basically 10, and then we've got like that, right? So this, you can do that, yeah, exactly. So but then then it shouldn't be +1, 3. Yeah, if I do that, which is how it's defined, I think we're running into the same problem. I'm just running in circles because you cannot why? Am I here? Like, is this really the row that is causing the problem? If I'm changing that, why the heck is it changing these? You know what I mean? This element here? There's something super off going on here. Like if I comment on this, is it just like, is it just not working or what? It's not to a max. Okay, now we're getting into, so now it seems like it's kind of working. So what's the size? As per these definitions, the matrix in main pi what's the size of, what's the shape? What's the shape of like xt times w? Hidden state. One hidden size. So then this was okay, how this was defined. Right? But now oh, okay, that's fine then. Actually, that's fine. Why? But then this is just wrong how the traceback is working here, because then that's okay, and then here this is where we get into trouble. A1 is just the tan x, the hyperbolic tangent, whatever that is, and then we've got the hidden size and the output size. A1. So A1 is going to be no, but it also doesn't make any sense. It shouldn't be 1 times hidden size. Yeah, it should be, because you're transforming it essentially. Okay, cool. Hidden size. That's why here we have hidden size in W2, so that you can actually then go ahead and multiply that as well. So why isn't that working? Why isn't that working? Fuck you. Okay, now, like, you see, this is just weird, man. Like, we used to get the errors in Z1, and now we're getting the errors in Z2, which, okay, kind of makes sense, but still. That just makes no sense. That is 5-3. And so five rows, 3 columns, and then we have 1 row, 3 columns. Shouldn't be a mismatch. So I should just kind of broadcast it, right? That's kind of the problem here, I guess. Should just repeat the operation. It should just add it everywhere, should it? So why is this size mismatch an issue in SymPy but not in NumPy? I guess the reason is that assumption, right? That broadcasting, exactly. That's what I thought. The fucking broadcasting from NumPy. That's these, right? Can add them. Okay. So here we have an input. So here we have. We might as well just get rid of these and then, because that just makes more sense. Here we have these. Multiply that, then you add. Be repeated. Yeah, okay, so you have to manually do these. What happens if I do that again? Are we still on track? Yes. dude, I have no idea what happened, but I think I played with these values and I was getting stuck somewhere else before, but now it's okay. So now we're stuck at the same place, and it's because of the broadcasting stuff that is missing, right? So we have we basically have A1 multiplied by W2 but something's not adding up. I think broadcasting shouldn't be needed, right? If the result of these is basically you get the outer size is one hidden size, then we add it with one hidden size. Then we multiply these, and we should still one output size. It should be fine. Why is it 5, 3? I don't get it. A1, W2. Hidden size, output size. I don't get it. It should actually be fine. This is a bit odd. A1 is not defined. What did we just say? Is that one? Oh, come on. That is just fine. Okay, I guess that is just that's a problem then. Because now I just went through and the problem is now with Max, right? So so now the question is why is these changing the shape somehow? So the line PAM in SymPy seems to change the shape of the matrix. I wanna apply 10x to each element. Maybe there's just a different way to do this. That's all. That's all. That's all. Yeah. Okay, that's fine. Doesn't change the shape. Squashes each number. Yeah, but it does seem to change the shape, bro. Or at least it's doing something odd where it then does the wrong estimation if it's because maybe it's doing some funny optimization just plugging it in here. Because if I do these sorry guys. If I do this here, I think I'm gonna get the same error. Yeah, I think it's just yeah, I think it's just expecting. So how do I apply? How do I apply a function to each element of a matrix in SymPy? I think that's what I want to do. I want to do it. I just want to do it differently. Apply function. Yeah, probably. Yeah, that's what we have to do. Interesting. Okay, so this is just Z1. That's what's gonna do it. That's what's gonna do it. Yes. So if we get it to run, then yes, cool. See you next time. At least we moved through 3 lines. That's awesome. Thank you.